Now work done in blowing a soap bubble. So it means we add some soap solution and then we blow it off. Now how much will be the work done in this concept? By blowing a soap bubble of radius R1, a bubble of radius R2 is formed. So initially the radius of the bubble is R1 and finally the radius of the bubble is R2 is formed and the work done will be twice of. Now work done is force into displacement. So it will be twice of 4 pi t into R2 square minus R1 square, and that is simplified to 8 pi t into R2 square minus R1 square because there are two surfaces of the soap bubble. Liquid film between the two parallel plates. So if a liquid film of area A and thickness T is formed in between the two parallel plates, the necessary forces required to separate the plates. The two parallel vertical plates keeping the distance between plates very small, very small. Dipped partially in a liquid, the liquid would rise in between them. The height of the liquid will be estimated by function. It is 2t cos theta over dgt. That is density into acceleration due to gravity. Now dependence of surface tension on temperature. So temperature also affects the surface tension. So surface tension of liquid decreases as the temperature increases. At critical temperature, the surface tension becomes zero. Critical temperature means where there is no further variation. The surfaces or the surface tension of the water at 0 degree is given to us. It is 75.6 into 10 to the power minus 3 Newton per meter, and at 25 degrees it becomes 72 into 10 to the power minus 3. So we are finding that the order of number remains 10 to the power minus 3 and the temperature has been risen from 0 to 25 degrees, and we find that surface tension drops. And if it is 50 degrees, it further drops to 67.9 into 10 to the power minus 3 newtons per meter. So what we find that the surface tension further decreases. Some effects of the surface tension. So how the surface tension shows the various types of effects. So here we have discussed that the raindrops, and the smaller raindrops are spherical and the bigger raindrops are flat. So drops of rain are spherical because for a given volume, the surface area of the sphere is minimum. A needle can be made to float on the surface of the liquid if the needle is kept gently on the surface. Spreading of hair on dipping a brush of the camel's hair in water and clinging together on taking out of the water. That is, they come close. Rise of the oil in wicks. When we speak of wicks, there is some capillarity in the wicks and small holes are there. So whenever wick is dipped into the oil starts rising in the wick due to the action of surface tension. Spreading of ink and absorption of ink by newspaper. So newspaper behaves like a blotting paper. It has got small holes. So when ink spreads on it, we find that newspaper absorbs that particular ink due to surface tension. To and fro rapid motion of objects on water when camphor is stuck on the surface of objects, that is, camphor begins to jump at its mean position. The coldness produced by spray. When we spray some liquid, then some cooling effect is produced. Dancing of camphor on the surface of water. That is, it experiences surface tension. Some important facts about the surface tension. Small drops of mercury are spherical and large drops are flat. I have explained it earlier that spherical drops are also facing the surface tension and large drops also, but large drops face more surface tension, so they become flat. The reason is mentioned, which I have now spoken. When a drop of any liquid is put on the horizontal glass plate, its shape is governed by two forces. One is due to surface tension and another is gravitational force. The drop acquires such a shape in which the potential energy is minimum. If only surface tensions were acting on the drop, its potential energy would be minimum when its area is minimum. For a given volume, the surface area of sphere is minimum. Therefore, the drop will be spherical if it is smaller. On the other hand, if the gravity alone were acting on the drop, then its potential energy will be minimum when its center of gravity is at lowest position, so that drop would spread. That is, it will be covering more area. For every small drop, potential energy due to gravity is almost negligible because the mass of the drop is small as compared to the potential energy due to surface tension. Therefore, the shape of the drop is determined by the surface tension and it should become spherical. As the size of the drop increases, the gravity becomes more and more effective because the drop is of the bigger size. Its mass becomes more and the drop loses its spherical shape, trying to be flatter.